In the next 5 minutes, we'll stand up a complete data protection and disaster recovery posture for a virtual machine workload in Azure, end to end. By the end, you'll know exactly which service does what, the order of operations, and the decision behind each step. Two services do the heavy lifting and people constantly confuse them. Azure Backup gives you point-in-time recovery of data and machines. Azure Site Recovery, ASR, replicates running workloads to a second region so you can fail over during an outage. Backup answers the question, can I get yesterday's data back? Site Recovery answers, can I keep running if a region goes down? We'll configure both against the same workload, run a real test failover, and verify it works. First, the decision that shapes everything. These are not competitors, they're complementary. Backup protects against data loss, corruption, accidental deletion, or ransomware. Its recovery point objective is measured in hours, and you keep many restore points over days, weeks, or years. Site Recovery protects against downtime. It continuously replicates, so its recovery point objective can be as low as 30 seconds, but it typically keeps only a short retention window of recovery points, around 72 hours. The rule of thumb, use backup for retention and compliance, use site recovery for business continuity. Most production workloads need both. Cost models differ too, so check current Azure pricing. But site recovery bills per protected instance plus storage and egress, while backup bills on protected instance size plus storage consumed. Step 1 in the build, create a recovery services vault. This is the management and storage boundary for both services. Place it in your primary region in the same subscription as the workload. Decide on storage redundancy now because some settings lock once backups exist. Choose geo-redundant storage if you want cross-region restore for backup or locally redundant if you're optimizing cost and accept single-region durability. One important constraint, for site recovery, your vault must live in a different region than the source you're protecting, since it's the failover target. So for a workload in East US, the vault and target sit in a paired region like West US. Plan your region topology before you click Create. Step 2, enable backup on the VM and attach a policy. The policy defines schedule and retention. For a typical production server, a daily backup with 30 days retention covers operational recovery, and you can layer weekly, monthly, and yearly points for compliance. Azure Backup uses an agent extension for VMs and takes application consistent snapshots, which matters for databases. If you're protecting SQL Server or SAP HANA inside the VM, use the workload-specific backup so you get log backups and 15-minute recovery points. Enable soft delete and immutability on the vault to defend against ransomware deleting your backups. Trigger an initial on-demand backup so you don't wait for the schedule to validate it works. Step 3. Turn on site recovery for the same VM. From the vault, choose the source region, the VMs, and the target region. ASR provisions a cache storage account in the source region to stage replication data, then creates the target resources, a replica managed disk, and a recovery network mapping so the failed over VM lands on the right virtual network and subnet. You define a replication policy with your recovery point retention and how often app-consistent snapshots are taken. Initial replication seeds all the data, then it switches to continuous delta replication. Critically, you build a recovery plan that groups machines and adds ordered steps and scripts so a multi-tier app fails over in the correct sequence, database before app before web. Step 4, and the one most teams skip, test failover. This is the whole point of the build. A test failover spins up your replica in an isolated network in the target region without touching production and without committing the failover. You log in, confirm the app starts, the data is current, and connectivity works, then clean up. Do this on a schedule, quarterly at minimum, because a DR plan you've never tested is a hope, not a plan. When a real disaster hits, you trigger an unplanned failover, pick a recovery point, and your recovery plan runs the ordered steps. After the source region recovers, you reprotect and fail back. Never wire your test into the production network. How do you know it's actually working day to day? Check the replication health in the vault. It should read healthy with the RPO within your target. Watch for jobs that fail, especially after VM size or disk changes, since adding a disk needs explicit re-enabling of protection. For backup, confirm the last successful job and watch for any in a warning state. Wire up Azure Monitor alerts and the built-in backup and site recovery reports so a failure pages you instead of being discovered during an outage. Track your real measured RPO against the objective you promised the business, and document the actual recovery time you observed during test failovers. Here's the build in one breath. Create a recovery services vault in a paired region. Attach a backup policy with retention and ransomware protection. Enable site recovery replication with a network mapping and an ordered recovery plan. Then test failover and monitor health. Backup is your safety net for data. Site recovery is your continuity plan for downtime, and serious workloads use both. Your one concrete action today: go run a test failover on something you already protect, because untested recovery is the most common and most expensive gap I see. Pricing and feature limits change, so confirm redundancy options and costs in the current Azure docs before you commit a design. If this helped, do me a favor, hit the like button, subscribe, and tap the bell so you don't miss the next one. See you in the next video.